Hey folks, well, I paused the video briefly in order to go look up the title of a book that I wanted to tell you all about, and when I went to turn it back on, the camera app quite simply shut down. Therefore, I had the video cut off early, so I'm going to give you this one last little bit, probably 5-10 minutes, in which we wrap up our Enlightenment science lesson just by talking about Thomas Young. If you are watching this and have not seen part 1 and part 2 of this lesson on Enlightenment science, go watch those first, unless you just want to hear about Thomas Young, in which case you can just stick around here. The book that I was going to go reference for you all, if you want to learn more about the guy I'm about to tell you about, a book called The Last Man Who Knew Everything by Alexander Robinson. Wonderful biography of Thomas Young that goes into this rather extraordinary scientist's life. Now, Thomas Young, true polymath. Scholar who was good at just about everything and made tremendous contributions to a wide range of fields. He could be called a physician, a physicist, a musician, an Egyptologist, a linguist, an engineer. Young was involved in a tremendous range of subjects and made positive contributions to almost all of them. Thomas Young straddled the boundaries between the Enlightenment and the 19th century. He was born in 1773, died in 1829. Young was born to a Quaker family. He was the eldest of 10 children. Brilliant from a young age, quite accomplished in a very wide range of areas. Young had, you might say, a gift for languages. Now, hopefully some of you in here know a second language. Maybe a couple of you know a third language. Any of you got 4? I don't. Thomas Young, by the time he was 16 years old, in addition to his native English, knew Greek, Latin, French, Italian, Hebrew, Chaldean, Syriac, Samaritan, Arabic, Persian, Turkish, and Amharic, several of which were obsolete languages by this time. It's 12 if you weren't counting. So, yeah, pretty good language guy. And he continued to be good at languages throughout his life. Those are the languages he was fluent in. He had a good understanding of the grammar and basic structure and was probably conversationally proficient in dozens more. Now, you might think, okay, this guy is going to be a linguist, right? That was a hobby. His real aspiration was medicine. He went to medical school when he was 19 years old, got his doctorate in medicine, his MD, by the age of 23. Set up a private practice in the city of London. Despite his independent wealth, he felt that it was a service to mankind. By all accounts, Thomas Young was a good person, gentle, kind, charitable, and humble. The fact that he was not really inclined to brag about his discoveries is probably a big part of the reason nobody's ever heard about the guy. And he spent his life dedicated to public service. He thought that his scientific research was fundamentally a gift to mankind, and that his medical practice was the single most important thing he was doing because he was helping people out. Now, Young did most of his research on his own time. He became a professor attached to the Royal Institutes, founded by Count Rumford in 1801. In just 2 years with the RI, he delivered a whopping 93 lectures. Eventually, he ended up leaving the RI in 1803 because he said that committing all that time to those lectures was interfering with his all-important medical practice. So, what kind of things was this fellow up to? Obviously, medicine is an important area of research for him. He makes some contributions to hematology. Young works out the first wave equations for tracking the pulse of the hearts and the movement of blood. He also studies the valves of the hearts, particularly where it interfaces with arteries. And in particular, he is interested in vision. He discovers and describes the phenomenon of astigmatism. And in 1801, he makes the prediction that color vision is the result of 3 separate kinds of nerve fibers sensitive to red, green, and blue lights. That is sometimes called the Young-Helmholtz theory, named after him and the German physiologist Hermann Helmholtz. And that idea was not actually definitively proven to be true until 1959. So Young was quite ahead of his time in deducing that. In the realm of physics, Young was quite gifted in the field of physics. He is going to conceive Young's modulus, which some of you might know is an equation in physics for relating the stress on a body to strain in the material that it is experiencing, vital to modern engineering. He's going to provide a modern definition of the concept of energy as we know it today, the ability to do work. He is going to devise the theory of capillary action and surface tension. His ideas will later be married to those of the French scholar Laplace to form the so-called Young-Laplace equation, which some of you might be aware of. And his most famous contribution to physics, and the one that got him the most attention during his lifetime, would be his study of light, unsurprising for a guy who is making studies of vision. Young studies lenses and their behavior quite extensively. Among other things, another physiological contribution, he's the first person to discover accommodation in the lens of the eye. The lens of the eye actually changes shape to accommodate light coming in at different angles and to focus on objects at different distances. As he is studying the behavior of light, Young concludes that the corpuscular theory of light as a stream of particles proposed by Isaac Newton a century earlier, is not telling the whole story. And Young thinks, according to his observations, that light behaves more like a wave. So he sets up an experiment to try this out, to figure out whether light is a wave or a particle. And I will show you right here. Give me just a second to sketch. That Young is going to devise a famous exercise. Some of you have probably heard of this before. Some of you might have done this in a physics class at some point, called the double slit experiments. The way your double slit experiment works is that you have two screens, one solid with two slits cut into it, the double slits, one screen behind it. You have two screens, one solid screen, one screen with two slits cut into it. What you do is you shine lights at your screens. Shine a beam of light through the slits in the screen. Now, Young says, based on the knowledge of wave interference, that if light behaves as a wave, whenever it passes through the slits in the screen, the waveform will be propagated independently through each of the two slits. You will see an interference pattern on the far side where the waves overlap each other. And as a result, you will have alternating areas of darkness and light cast on the solid screen beyond. Whereas if light behaves as a stream of particles, then it's going to just shine straight through the slits, and you'll have 2 points of light on the screen beyond. Like what I have just drawn for you here. Here's our double slit experiment. On the right there, you see what happens if light behaves as a particle. You have 2 points of light on the opposite screen. On the left, you see what happens if light behaves as a wave. You see the waves hitting the first screen, propagating separately through the second two screens, and the interference pattern between them creating alternating bands of light and dark on the solid screen on the opposite side. You can demonstrate this quite easily with double slit experiments using waves of water passing through a screen when you slosh the wave. But Young was trying it out with light. And as many of you are no doubt aware, if you do a double slit experiment, you can try this yourself, then on the other side, you will in fact see alternating dark and light patches on the far screen. Thus, Young demonstrated that Isaac Newton was wrong. First time anybody's disproven one of Newton's ideas, that light does not behave as a stream of particles, it behaves as a wave. So he's kind of the father of modern wave theory in that way. And yes, I know, quantum physics, light acts like both a wave and a particle. We'll get to that when we talk about the 20th century. But for the time being, Young has given us a wave theory of light, which is vital to the understanding of the mechanics of light and electromagnetic radiation. In pharmacy, Young is going to devise Young's rule, which is a principle in pharmacy for calibrating the dosages of medication to the body sizes of children. He is going to make a contribution to music, developing Young's temperament, which is a method for tuning musical instruments. And in the realm of language, he's going to make a detailed study of the grammar and syntax of more than 400 languages. He's going to conceive of the idea of the Indo-European language family. And a lot of this is going to become crucial to the structure of the modern science of linguistics. His most famous linguistic accomplishment is actually something he didn't get into until a little bit later in life. In 1813, he became interested in Egyptology and set his linguistic talents to trying to decipher hieroglyphics. Now, in 1799, Napoleon's soldiers invading Egypt discovered a slab of rock containing the same inscription in 3 different ancient languages. That slab of rock is named the Rosetta Stone, after the site where it was discovered. The Rosetta Stone contains the same inscription. It's actually a royal proclamation from about the 1st century or 2nd century BCE, written in ancient Greek, in hieroglyphics, and in a later Egyptian script called Demotic script, a script that was both alphabetic and ideographic. Now, ancient Greek was well known. So a bunch of linguists said, well, hey, we can use the ancient Greek text here to try to figure out the hieroglyphic and the demotic texts and actually translate ancient Egyptian writings for the first time. A lot of different people are working on this. It's an exciting area. Young gets into it in 1813. He corresponds with the primary French scholar who's working on this, a fellow by the name of Jean-Francois Champollion, Champolilion. The 2 men work together on trying to decipher the Rosetta Stone for a couple of years, but there's kind of a falling out between them. Their relationship gets a little bit more distant in about 1815, and they kind of go their separate ways. Champollion will ultimately be the first person to translate the hieroglyphic portion of the text, but Young is going to successfully translate the demotic script, the later post-hieroglyphic Egyptian alphabets. Well, partially alphabetic, partially ideographic, and he's going to realize it's a mix of different kinds of symbols. Indeed, Young's work with demotic ends up being a really crucial factor in Champollion's contributions to translating hieroglyphics. And there are some of Young's boosters who argue that he had actually plagiarized from Young and did not give him sufficient credit for his contribution to figuring out hieroglyphics. Young himself, whenever the hieroglyphic part of the text was translated in 1822, was pretty gracious about it. And he actually praised Champollion for his work. The 2 men later kind of got together, and Young visited France and actually saw some ancient Egyptian texts that Champollion gave him access to. So Young has an important role in Egyptology, helping to translate one of the chief ancient Egyptian scripts and thereby opening the doors for a lot of learning about ancient society that we otherwise didn't have access to. So Young has an incredibly diverse career. He's contributed to ancient history and archaeology. He's contributed to linguistics, to medicine, to physics, to pharmacy, to engineering, even to music. Not a bad resume, especially for a guy who dies at the age of 56. Despite years of clean living, he did not smoke, he rarely drank, lived a largely vegetarian diet. Young died of atherosclerosis, hardening of the arteries, which seems to have been preceded by what they called asthmatic symptoms at the time, which we are realizing is probably actually congestive heart failure. But yeah, he died when he was only 56 years old, probably from congenital hypercholesterolemia as a result of that, given his relatively low-fat diet. And therefore his achievements were cut short probably by a couple of decades. It's anybody's guess what he would have achieved had he not passed away when he did. All right, so that is the story of Thomas Young, the last man who knew everything, and a fellow who everybody should know about, but so few people do. And that ties off my look at science in the Enlightenment. I appreciate your persevering, especially through this somewhat broken up into chunks lesson. I hope you all enjoy, and I will talk to you later. Our next lesson is going to deal with the 3rd great scientific revolution. So tune in next week for the Darwinian Revolution. I'll see you all then. Good night.